Okay, yeah, I think everybody can probably hear me now because I forgot to switch on my audio. So, welcome, hello, welcome to the Oklahoma City Astronomy Club April meeting. We're meeting virtually this month because we were having a scheduling conflict at our normal meeting site, which is the Science Museum, Oklahoma. Um, oh, I apologize for that. All right. Hopefully nobody else will call me while we're having our meeting here. So I'm filling in for Danny this time. He normally does these virtual meetings, and he had other commitments this time. It was kind of unexpected that we'd have to do this virtually, so I'm picking up for him, and been learning all the little streaming bits and pieces of how to put this together. So bear with me. Hopefully I won't get too confused during this deal, and won't have too many more audio problems if I can remember to keep the mic turned on. So, all that being said, Oklahoma City Astronomy Club, we're we have over 200 members. We founded in 1958. Been around a while, and we have our normal club meetings every month on the second Friday at 7 p.m. Normally in person, but virtually whenever we have something come up, whether it's weather related or in this case a scheduling conflict. So our next meeting would be on Friday, May 9th, and that hopefully will be back at Science Museum, Oklahoma. So we'll see you guys all there next time. We have with us that's going to do some presenting, Eileen, and then she's going to introduce our main speaker tonight, who's going to do a presentation, and she'll tell us about that presentation here in just a little bit. We also have Mike Mitchell, or Mitch as he likes to be called, because we have too many mics. So Mike is going to talk to us about some of the events coming up. He's our observing coordinator. And so Eileen is our program director, if I'm remembering that correctly. So we just as a couple of things I'll mention, and let me switch the view here. I'm going to share my screen. And so that you can follow along as I'm talking about this. Transition into that. Okay. Let's see. This is what I actually want to do right here. Okay, that was Eileen that popped up there for a second, but we'll get around to her here in a minute. So some of the things that are coming up this month, we have a novice session that's coming up next Saturday on the 12th, and that's going to be at Lake Hefner. This is a regular club event, an outreach event. Anybody that's got a interest in telescopes, or maybe has a new telescope and is trying to learn how to use it, feel free to come on out. And we should have plenty of members there at Lake Hefner, which is a nice place to meet. A little bit heavy on light pollution since it's in the city area, but it's a fantastic place to go as long as the weather and the sky is good. So we'll be able to help. There'll be plenty of telescopes and eyepieces. People like to share, people like to talk about their stuff. You have questions, if you're trying to decide what kind of telescope do you want, or if you're just want to see everybody else's telescope, or if you've got one and you're not quite sure how to operate it, there'll be people there that can help you out. That's the main purpose of that novice session. So that's, again, Saturday on the 12th. Then at our club observatory site, which is Cheddar Ranch Observatory. This is a site that's out kind of to the southwest of Watauga, Oklahoma. It's in a darker sky area, not too much light pollution, hopefully, if there's not a lot of oil or gas exploration going on. And the windmills aren't encroaching on us quite yet. So it's still pretty good skies out there. We can see Milky Way when that's up there. But anyway, we have club member nights on the 19th and the 26th. So those are any member of the Oklahoma City Astronomy Club, and if you're a member and you want to bring a guest along, that's okay too. You come on out, and we have 10 observing pads, 10 foot by 10 foot observing pads where you can set up telescopes, or if you don't have a telescope, you can walk around and look at everybody's, or you can look at our 14-inch telescope, which is in our roll-off roof observatory there on site. And then we have another telescope if we manage to get it operating for one of those or both of those nights. It's a 30-inch Dobsonian telescope on a go-to mount. So that's a pretty nice piece of observing equipment. We don't always have that dome up and running, but that's a 15-foot dome. But hopefully, especially if the weather's nice and not too windy, we'll break that out. You can have people in there looking at that. Of those two nights, we're devoting the 26th to the Messier Marathon. So that's just an annual kind of astronomy event where the sky is positioned well enough to where you can actually go through all the Messier objects. And there's a poster here on my back wall which kind of shows those objects, and there's according to this poster, there's 110 of them, which is probably about right. There might be a couple more, but I don't think so. I think that's all Messier himself cataloged. But these are all just deep sky objects. He thought they were all comets at the time, and then as we got better telescopes and better research, we figured out a lot of those are actually galaxies and nebulas and other fun things to look at. And so those are all mostly visible in pretty, not too big of a telescope and a nice dark sky area. And CRO is pretty ideal for that. If you want an even darker sky area, we have an annual event called the Okie-Tex Star Party. And that's done out in the Panhandle of Oklahoma near a small town called Kenton, which is as far to the west in Oklahoma in the Panhandle as you can get before you can throw a rock practically and hit New Mexico or Colorado from there. So, but that's the Black Mesa area. The elevation's over 4,000 foot. It's a semi-arid desert area, so that's perfect place to have a star party. Very, very dark skies out there, some of the darkest skies in the country and really in the world out there. So we love to have our star party out there every year. And actually, I'm forgetting off the top of my head just when that is this year, but looking at it real quick. This year, the Okie-Tex Star Party is going to be from September 19th to September 27th. And so make your plans. It's a big campground. We've got facilities out there, bathrooms, and they cater, have food, an on-site kitchen. This is a campground that's normally used for a lot of different organizational purposes. We have large fields. We get, pretty regularly about 300 people on site signed up for this thing, and it'll be different numbers of people on, depending on what part of the week it is, because some people come for the first part of the week, some people come for the last part of the week. Sometimes people, get worried about cloud cover and things like that, and so, but if we have we had a really good year last year, a beautiful event, hardly any rain, hardly any clouds. So we had a lot of good nights of observing out there last year. And hopefully we'll be able to do that again this year. So it's a great star party. I got people from all over the country and sometimes other places around the world to come and visit that. So and we'll be talking a lot more about that at our monthly meetings as time gets closer and closer. I don't think we've opened up registration to it yet, but I may be wrong on that. I don't think we have, but as soon as, well, let's just check it out. Online registration. I think maybe we have opened it up. So you might be able to go ahead and get registered for that. It's not a free event. So, but, it's a little bit of a commitment, but it's not exorbitantly priced, especially compared to some other star parties out there. We offer, you can tent, you can bring an RV, whatever you want to, big field, we put power out on the field so you can hook up all your equipment. And like I said, there are bathrooms. We have a building that's dedicated just for doing indoor presentations, and it also has additional bathrooms in it. So it's a great place to go and have star parties. We have speakers that come out during the day and so talk people in astronomy and looking at all different aspects of whether it's astrophotography or optics or mirror design or building telescopes or even going out to interesting places and doing astrophotography or comet hunting. We get all kinds of speakers that come in there and do things. So that's it's a premier kind of part of the event actually, just to attend those speaking sessions. So at any rate, you can check that out. That's on our website. This is our website home, and that's actually, this is the OKTEX website. So if I get back over to the Oklahoma City Astronomy Club, there we go. So that's our main website for the Oklahoma City Astronomy Club. And from there, we can also get things like our event calendar. There's also our discourse server, which is actually our discussion forum, and we've got all kinds of topics out there. People post things. This is our main way of communicating in the club about events and really all kinds of different topics. So it's a great way. We also have a Discord out there for club members, and a lot of discussions happen out on Discord as well. So we have all those things available. Also, I want to mention real quick about our monthly newsletter, the Gazers Gazette, and this is the April edition, and we'll go through there. We have a message from our president, Ron McCollum, and so that's a good thing to read through. And then it talks a little bit about upcoming events and so forth. So that's something that you can go out, and also talks about some of the things that are coming up. And here's what Eileen's going to be discussing, which is our speaker presentation. Let's see. So getting back to the events calendar, we've got those things going on at Cheddar Ranch for club member nights, novice session. And this is that club meeting, of course. Tonight we have a board meeting coming up on the 22nd. So our board officers get together, and that'll be held this month at a place called UDT, which is helping to donate a facility to us. Normally we'll meet at a library, so forth, when we can get those things scheduled. But this month we weren't able to get a library room scheduled for that, so we'll be meeting at UDT offices. But those are open to club members to attend. It's actually anybody in the public that wants to attend that is welcome to come. That's part of our club charter is that those are open meetings. So the details on that are here on the event calendar for you to drill down onto if you'd like. And here's what happens when you look at the novice session. You get all the information of where that's at, and then same thing for everything else on the calendar. So what else do I want to talk about here? We talked about the club. So I want to take a real quick look. We've got 27 people watching right now. We've got a few things going on in the chat. People saying hi. That's all good. Feel free to like if you do like it. Feel free to like this. We're not monetizing any of this, but maybe in the future, we could do something like that. We're a nonprofit organization, but when the club does get donations, or we make a little bit of money off of a Star Party, attendance or something like that, that all goes back to the club, and we reinvest it in things for Cheddar Ranch Observatory, and that's how we've built those facilities out there. So we also have a First Friday public viewing coming up on May 2nd, and that'll be at the Arbor Gardens Park in Moore, and Mitch will probably tell you some more about that, but that's a great little public outreach event to go to, and people will set up some telescopes, and people will come and look through eyepieces and have a good time. Also, I want to mention something that I get involved with every year, pretty much every year. We have the J.D. McCarty Center is holding their summer camps for children with disabilities. These are kids age like 8 to 18. But they have a series of summer camps. This year there will be, I'll make sure I get this right. Yeah, 5 camps. And those are going to be on June 2nd, June 9th, June 16th, June 23rd, and July 14th. And then we have alternate nights of those in case of weather on the following nights. So on the June 2nd, that's going to be on June 3rd for the alternate date. So just a quick mention on that. We've got a posting on Discourse with all that information. And we've also got those events already populated out on the calendar for you to see. So those events, we like to have at least a couple of club members come out and volunteer to work with these kids. And they are, these are kids with physical disabilities. And so sometimes they have trouble looking through eyepieces or, motor movement, fine motor movement skills. So, if you've got a telescope and you like working with kids, and these are great kids, feel free to come out to that and set up what you got. And it doesn't matter how big of a telescope you've got. Probably, too big of a telescope would be too hard for some of these kids to get up to. So smaller telescopes work great. Or if you've got a way of projecting, from your eyepiece onto a screen, we have a member that comes out and does that every year. So that's always fun for the kids. So hopefully we'll have good weather for all that stuff. One thing I want to mention real quick, and this is sad. We had a member who recently passed away. His name was John Hanna. And I met John back when I first joined the club back in about 2013-ish. And I have a lot of good memories about John. He used to hang out at CRO on club nights, and many a time that we'd be out there helping each other with telescopes and looking at things and talking about stuff. He's also has been a regular fixture out at Okie-Tex for many years, and actually introduced all our prizes and things out there for door prizes. That's something else we do at Okie-Tex. We have a couple of door prize events. we give away to attendees, different stuff. But yeah, John was a big part of Okie-Tex for many years. So it's sad that I wanted to mention that, and because this, I think, was worth mentioning. So at any rate, I think that's pretty much all that I'm going to talk about for right now. I'm going to go ahead and get things moved along to Zoom here. And we've got Eileen getting ready to jump in and talk about some things. And we get this going, and I'm going to change my view to full screen. And Eileen, are you there? All right. We're not hearing you yet. So this is part of the audio issue. Eileen, hold on just a minute. Hold on. Hold on, Eileen, we can't hear you. We can't quite hear you. Hold on just a second. Guys, we can't hear you just yet, so hold on. At least I'm not hearing it. Maybe, tell you what I'm gonna do, maybe it's just because I'm not hearing it here. I apologize for the audio issues if there are any. Let me. Okay, did that fix anything? All right, Mitch. Okay, I'm still not hearing you guys. Okay.
Can you hear me?
Now we got it. Now we got it. All right. Sorry about that, everybody. Go ahead, Eileen.
Can you hear me?
Now we got it. Now we got it. All right.
Okay.
Sorry about that, everybody.
Okay. Just so you know, our speaker last month.
Go ahead, Eileen.
Thank you. Our speaker last month, Dr. Mark Raymond, will be our speaker in May. Can you hear me?
We can hear you.
I've got to do something, and just so I don't hear. Okay. I will turn that off because I'm echoing. Sorry for that. And now I can proceed through. But our speaker, Dr. Mark Raymond, is going to be with us in May instead of March. And he definitely understood because he was a victim of the fires. And when I called him that day to just explain what was happening, he quickly pulled up the satellites pictures, and he said, "Oh my gosh, you guys are really in trouble right now." And so we understood, and he understood, and he offered to speak on May 9th. So that's our next meeting as far as that goes. Tonight, I would like to introduce Waylon, and Waylon is going to speak about astronomy in Chile from desert to dome. Waylon is the current director of the New Loves Planetarium at the Science Museum of Oklahoma. He has been working at the planetarium since 2017, and then between then and now, he earned his bachelor's degree in astrophysics from the University of Oklahoma. And so he's the one that is really in charge of bringing this new planetarium. And I've had several people who have been up from Norman recently, and they said it's amazing. And we've all had a chance to see it, but I will give you this word of advice. When you go in, sign up for your planetarium presentation right away and stick to that time, because the schedule fills up very quickly. But I also have had the privilege of being part of the program that Waylon participated in last June. It is called ASIP, Astronomy in Chile Educator Ambassadors Program. And I participated in it in 2018 from the standpoint of being an educator and a classroom educator. Waylon has been part of it, and there's a very active group. All of us in ASIP are still connected with each other, and I often get ideas of who to bring in as speakers. But he is part of a very, very active group that are the planetarium educators and how they are using this information about Chile. So he was able to do the Chile trip and visit all the big eyes in Chile last June, and that's what he's going to talk to us about tonight. But studying the entire universe is no small effort, and no single telescope can do the job alone. Astronomy relies on teams and facilities around the world, spanning multiple countries, languages, and cultures. With radio arrays in the deserts of Chile and Alma, and the Australian outback, neutrino detectors in Japan, and optical telescopes across the northern hemisphere, astronomical research is one of the largest global scientific efforts in human history. So who are the people that make it all happen? What does it take to keep it running? What big things can we accomplish? And especially we're using the big computers, the big data collecting computers. During Waylon's time with the Astronomy in Chile Educator Ambassadors Program, he was able to visit some of these facilities in person and find the answers. So in this presentation, Waylon will share that experience with us and paint a picture of what modern astronomical research looks like on a global scale. He'll also take a look at how these projects and their stories are transferred into the planetarium to teach all of us and beyond. So I am honored to present Waylon Troyer. Thank you.
Hello. I'm going to give it just a second to make sure everybody can hear me okay and see me. Since the YouTube is delayed, I'm not sure. I also have a cat who's going to be joining us for most of the evening, but for now can go.
We are having some streaming issues. Waylon, we are having some streaming issues.
Okay. Is there anything I can do? Do you need me to wait just a minute?
I don't think so. Yeah, let's hold up for just a second. I'll see if I can. I think I know one thing I can do here. Just a second. We are experiencing some resource constraint. Okay, let's give that a try.
Okay. Hopefully everybody can hear me all right. If not, just stop me and we'll see if we can tweak it. Are you also able to see my screen okay as well?
We can see your screen just fine.
Excellent. Okay, so we'll go ahead and get started, and I'll try to speak a little more clear than I normally do. But as Eileen was saying, we're going to talk a little bit about astronomy in Chile, and specifically talk about some of the things that I learned and some of the things I got to experience that I actually get to bring back to the planetarium. Again, sorry, my cat's tail and rear end will be joining us for a good portion of the evening, so hopefully that you can still see the slides. So I've kind of broken it up into 4 sections. So we'll start with just a very quick look at what took me to Chile in the first place, why Chile at all, and just kind of give you a brief overview of most of the important foundations for this conversation. And then we'll take a brief look at what I like to call a few flavors of astronomy. We'll talk, that'll make a little bit more sense here in just a minute. And then after that, we'll look at some of the instruments I was able to visit and some of the ones that are critical in the larger astronomical projects that are happening right now. And then finally, we'll take a look at the people that I got to meet during my time there and the people that actually make all of this happen. So of course, there's a lot I could talk about, and I am definitely not known for being a man of brevity. So I don't have time to, of course, cover everything, but I'll try to get as much as I possibly can, and still leave time for some questions. So I guess just really quick, a lot of you have probably met me before, but in case you haven't, I am Waylon. Hello. I have been at the museum for a while, like Eileen said, and I'm also a dad. I'm also a husband. So here's some fun little pictures of my family. There's my planetarium family down in that bottom right picture. And there's a couple of cool pictures of me while I was in Chile, I guess. I'm not a very photogenic person. So there's not a lot of cool pictures of me out on the internet or anywhere for that matter. But let's talk about the important stuff. And that first section is just going to Chile. Didn't really have any other better way to start that, to name that. But we'll start with the program itself. And again, that program, we just call it ACEP. It is a long name, but ACEP is a good acronym. It stands for Astronomy in Chile Educator Ambassadors Program. This is actually a project that is funded by the National Science Foundation, and it is a collaboration of a lot of different entities. You've got AURA, you've got NOIR Lab, the NRAO, which is the National Radio Astronomy Observatory, and then you've also got ALMA is a very big partner in that as well. And we'll talk a little bit more about ALMA a little later on. That's one of the facilities I was able to visit. But this is a really exciting program, and basically what it does is it takes astronomy educators of any kind, whether you are a K through 12 astronomy or physics teacher, or you are somebody who volunteers and does local lectures at an observatory, a small observatory nearby, or maybe you're somebody in the planetarium industry, whether you're a director or a presenter, or maybe you're a professor at a university and you teach graduate students about astrophysics or whatever it might be. It's a program for astronomy educators of any kind to visit several different facilities across Chile to learn about a lot of different things. They actually describe it pretty well in their two main goals that you can find right on their front page of the website. Their first goal is to inform amateur astronomers, planetarium personnel, and K through college astronomy educators about astronomy facilities in Chile, including the nature of their work that's being done by the scientists and the engineers at these facilities, and how they can access and use that data that's being collected and other resources from those observatories. So that's their first main goal. But their second goal is to create a core group of individuals, which the ACEP program refers to as ambassadors, who will broadly disseminate information from the AUI, AURA, ALMA, NOIR Lab, and NRAO. But those individuals are hopefully able to disseminate information and resources to the general public and K through college learners as well. So that really defines what this entire program is. And I was very thankful that I applied in 2022 I guess it would have been beginning of 2023 actually, at the beginning of the year in 2023, and got an email about 2 weeks after that, and was told that they were interested in having me. I honestly did not think I would get into this program. I had just started my time as a planetarium director like 2 months before I did that. I actually almost didn't even apply until the night the application was due. I was talking to some friends and mentioned, oh, that thing was due tonight. I never finished it. It's okay. Maybe I'll apply next year. And then they just convinced me to apply anyway. So I literally submitted my application at about 11:50 p.m. that night, and then got accepted about 2 weeks later. So I'm really glad that I did. This was an experience that, was very impactful on me. I could talk about it for so long, and I'm sure a lot of you have heard some of Eileen's experiences from when she went a few years ago. But I'm hoping to spend more time talking about the important stuff and less time talking about me. I don't like talking about me very much. But I do have some fun pictures that I'll bring in for my time. Um, so I guess another important question that I get asked a lot in the planetarium specifically by any kind of guest is, why do we focus on Chile so much in the astronomy world? Why are all these telescopes in Chile? Why do we talk about it so often in astronomy, and why is it so important? Things like that. And it's an excellent question. But really, there's a lot of reasons. I've kind of narrowed it down to three big ones, I guess. The first one, and probably the most relevant, the most immediately obvious, I guess, is that Chile is home to literally the darkest and clearest and most calm skies that you can find anywhere on planet Earth. Better than the middle of the ocean, better than the Arctic Circle or Antarctica, better than even Okotoks, right, out in the Panhandle. These are the best skies that you can get on planet Earth. They have dry and clear skies, near perfect conditions, over 300 days out of a single year. That's pretty impressive. So as a result, about 70% of all astronomy infrastructure that exists today actually exists in Chile. That's how good these skies are. Part of the reason for that is there's actually some really interesting geology reasons and meteorology reasons. It has to do with the shape of Chile and how most of Chile itself just lines along that western coast of South America, and the way that the air currents and ocean currents kind of meet up to create a barrier right along the edge of the mountain range that cuts on the eastern side of Chile. So you essentially get a wall of protection from all of that turbulent atmosphere right next to the ocean. And what you end up getting are these mountain ranges that are incredibly high up and also incredibly dry because of their atmosphere. So they're actually a desert. It's a very, very large and very dry desert. You have these mountains that are way up high, way above the cloud line, that are completely or nearly completely dry. So, of course, you might want to put a telescope on top because that's what every astronomer is looking for, clear and dry skies, right? So that's the, I guess, more obvious reason. Another reason we talk about it a lot is kind of a consequence of all these perfect skies in Chile, and it's that the United States alone, just the United States, has invested over $1 billion in astronomy in Chile on its own. Just astronomy in Chile in general, whether it's funding programs in science, whether it's funding observatories, whether it's funding research and development for different instruments and vehicles even. We'll get to that when we get to ALMA. The United States funds a ton of science in Chile because of these perfect skies. And we'll kind of break it down more. It's not just the United States, but we'll break it down more with each facility here in just a minute. And then, of course, another important reason that we talk about Chile so much is that ever since 1992, Chile and the United States have actually been in something called a Science and Technology Cooperation Agreement. So we essentially signed an agreement in the early 90s to say, hey, we have a lot that we can get from each other in terms of the research that can be done here. And it turns out it's a lot more than just astronomy. Chile has some very large mines. In fact, one of their biggest exports, apart from science, is things like iron ore, for example. I mean, they just export tons and tons of ores and minerals and gravel and things like that. So Chile is a big. That's hopefully, if somebody can let me know if they can hear me now. My headset decided to die on me right now, of all times. Did somebody pop in Zoom for a brief moment to let me know if they can hear me? Oh, I'm getting a thumbs up. Okay, excellent. My headphone decided to die. I apologize for that. Anyway, so yeah, that being said, there's a lot that we can gain from each other just in science alone. So Now that we've kind of gone over that, the second section, the second thing I want to talk about are a few important flavors of astronomy that are going to be really helpful when we start talking about some of the facilities in Chile. What I mean by flavors of astronomy is it's kind of two unique ways of doing astronomy and doing astronomy and astronomical research. This will make more sense once I go to the next slide. This is something that you might have heard of. A very important and popular flavor of astronomy right now is called time domain astronomy. This is essentially the study of how astronomical objects change over time. It's very simple, right? I mean, it sounds like, isn't that kind of all astronomy? But not necessarily. Let me give you a few examples. The three that immediately come to mind are things like exoplanets, gamma ray bursts, and asteroid trajectories, asteroid watching, or asteroid, stalking in a way, on an asteroid watching. These are events that happen in the universe that we want to watch over long periods of time. Because, of course, every time you go outside and you take a picture of the Crab Nebula, you're technically looking at things over time because it's always changing and the universe is always, it's dynamic, it's in a constant state of flux, and yada yada. But for example, we'll start on the left with TESS, with exoplanet research. One thing that's really important about understanding exoplanets is finding them in the first place. And for a long time, that was really tricky. In fact, people didn't even know if we could ever see planets around other stars, which that's exactly what an exoplanet is. If you're not familiar with that term, it's just a planet around another star besides the sun. So one great way to find new exoplanets is to watch them as they pass in front of their star. If you're measuring the brightness of a star, I'll move my hand, I guess, this way. If you're measuring the brightness of your star and something passes in front of it, blocking it, then it's going to reduce the brightness of the star. That's what we call a transit. You can watch Mercury and Venus transit the sun. You can watch the International Space Station transit the sun. But from our perspective, that doesn't dim the sun very much at all. Those are very small objects. But when you've got another star way out in the Milky Way and a planet, even a small planet, that orbits around that star, as it passes in front, if you're viewing from the right angle, you can measure the difference in brightness. So if you want to find those transiting exoplanets, you need to measure the brightness of lots of stars repeatedly for as long as you can, because you can have short period exoplanets that take only 12 hours to go around their star, or you can have planets like those in our solar system that take multiple years to go around their star. So that means you need to watch and measure that brightness for long periods of time. That is time domain astronomy. You've also got another observatory called Fermi. This is actually one that I've worked with. I worked with some data from Fermi while I was in college, studying gamma ray bursts. Gamma ray bursts, just to provide a little bit of context, are bright flashes of gamma ray light from very distant galaxies, active galactic nuclei, which are the very active cores of galaxies that are just really, really far away. They have supermassive black holes at their cores, and as they pull in material falls in, they occasionally have these outbursts where maybe they pull in a little bit more material than usual. Maybe a big clump fell in, and they'll burst out with a bunch of extra gamma rays, a lot more than usual. So it's a flash of light, and these can usually last a couple of hours, maybe a day or so. But if you want to map out the universe and all the quasars in the distance, if you want to understand the physics of black holes and all these other interesting particle physics that you can study, you need to be able to watch for those gamma ray bursts. So that's exactly what Fermi does. It's a space telescope that orbits the Earth and makes these full gamma ray maps of the sky about twice a day, and it's every day. I mean, it's constantly going around. Sorry, you might hear my dogs bark as well. I live in a zoo, so. And then, of course, finally, we've got WISE over there on the right side. I'm already spending too much time here, so I'm going to try to speed myself up. But you've got the WISE telescope. Nowadays, it's known as NEOWISE. I actually believe NEOWISE just finished operations earlier this year, late last year, something around there. But WISE was great at watching small, quick-moving objects across the solar system. So asteroids, comets. NEOWISE, WISE did a lot of transient objects, things that come and go in the sky, or things that move in the sky. But the neowise stage of this telescope was specifically for near-Earth objects. So it looked for comets and asteroids. And in fact, this little animation down in the bottom right is a time lapse of one of Jupiter's smaller moons. So these are all examples of time domain astronomy. And just to kind of give you an idea, you can really break it down into three different types of events. You've got periodic events. So if you're studying pulsars that appear to be flickering in the night sky, these rapidly rotating dead stars, neutron stars with jets, you want to measure their period and how quickly they're spinning around and flickering. That's a type of time domain astronomy. You have quasi-periodic events, which are things like gamma ray bursts. They happen with some amount of regularity, but not an exact, precise regularity like a pulsar would have. And then you have transient events, which can be a lot of different things. Things like a supernova, for example. It is a bright flash of light in the sky that lasts for a couple weeks maybe, and then slowly fades out. It is a temporary sort of event. So, for example, a lot of you maybe know about T Corona Borealis, a star that will go nova sometime this year. That event around that star system occurs about every 79 to 80 years. So T Corona Borealis is a transient event. And I've got just an example of a time domain astronomy project over here on the right. That's the growth project. But it is time for us to move on. The second flavor I want to talk about is something called multi-messenger astronomy. This is another very big one. It's not like it's a brand new thing, but this really started to kick off around the time of LIGO, an observatory that studies gravitational waves. We'll see that in just a second. But multi-messenger astronomy is the coordinated observation and analysis of multiple signals received from the same astronomical event. So what in the world does that mean? Well, okay, imagine you're at the LIGO Observatory, the Laser Interferometer Gravitational Wave Observatory, and you are watching a black hole merger. Two black holes that are orbiting each other and getting closer and closer until they and merge into a singular black hole. You expect that they produce gravitational waves, which LIGO is designed to measure. But you need to confirm that that's actually what you saw. So you need a different telescope, a different observatory that doesn't detect gravitational waves, but maybe it's looking for bursts of gamma rays, right? And you can see, okay, if we detect gravitational waves from LIGO in one spot in the sky, where this black hole pair is, this black hole binary system is. And then Fermi sees a gamma ray burst at that exact same spot in the sky. That's pretty good evidence that that's actually what we just witnessed. So this happens all the time now. But back in around 2013 was really the first time this started happening with gravitational waves, because that was the first detection of gravitational waves. But just as a very specific example, in 2017, we had this gravitational wave object. There's no pretty pictures to show you because gravitational waves can exactly photograph those. It also doesn't have a very pretty name. It's called GW170817. Kind of boring. But it was a gravitational wave event that was detected by LIGO using laser interferometry. The burst of optical rays was detected later thanks to the smoke telescope. And the gamma ray burst that was associated with that exact same event was also detected a few hours later thanks to the Fermi Space Telescope that we saw just a minute ago. So this is what multi-messenger astronomy looks like. You are watching one event in the universe, but you are looking at that event and detecting it with multiple different methods, whether that's optical telescopes and gamma ray telescopes and X-ray telescopes, or maybe that's gravitational waves and radio telescopes and things like that. You're just you have multiple messengers, multiple ways of watching an event, and you're taking information from all these types of messengers, and you're using it to make a more informed analysis and draw more informed conclusions about what event you actually just witnessed. It's a big deal in astronomy right now. It's kind of a hot new thing. So it's kind of an important one. Those are our two flavors of astronomy that I kind of wanted to touch on. I'm going to also make sure my notes are pulled up on my phone, just so I can make sure I don't forget anything. And I can see my clock so I don't talk for too long. Another great example, just really fast, is something called the supernova early warning system, SNOOS, as you will. I think it's kind of a funny name. SNOOS, oh, here we go. Boink. Sorry, again, looking for my notes. SNOOS is exactly what it sounds like. It is a system of telescopes, a collection of, in this case, not necessarily telescopes in the traditional sense. It's actually a collection of neutrino detectors. Yes. Nope, just kidding. Sorry, my notes are deciding to pop up. Speaker notes. That's what I was looking for. So it's actually a collection of neutrino detectors around the world because in the 80s, late 80s, we discovered that when a supernova occurs in our night sky, we can actually detect a burst of neutrinos. It's a type of subatomic particle that makes up the universe. They speed of light, and they also pass through physical things. So neutrinos are passing through you right now. You can thank the sun for that. A lot of neutrinos are passing through you right now, and through my screen, and through my cat down here. But neutrinos are just a type of subatomic particle. And in 1987, we realized, as we witnessed this first flash of optical light from a supernova was detected, and later we realized, some of our neutrino observatories detected a burst of neutrinos about 3 hours before that supernova happened. So we kind of waited for another event like this to happen, and they realized, it got here a couple of hours before the flash of optical light. It's kind of strange, right? So now there's a really strong relationship, at least current research suggests that there's this strong correlation between burst of neutrinos that happens very shortly before a supernova. So if you want to always be prepared for an awesome supernova, maybe Betelgeuse is catching up to us, and it's already gone supernova, and that light gets here tomorrow, and you want to be ready for it. You have no idea that it's coming tomorrow, but you want to be ready just in case. If you've got neutrino detectors, in this case, 7 of them scattered around the world, you can keep an eye out for those bursts of neutrinos. So hopefully you've got 2 or 3 hours to call somebody up and say, hey, go point at this spot in the sky, a supernova is about to happen. It's really cool. But this is a huge multi-messenger project. Even though they're all neutrino detectors, unlike our previous example, you are still measuring something and detecting something from different parts of the world with the express purpose of basically corroborating something. Like, hey, we got a burst of neutrinos. Did anybody else catch that? I want to make sure that this isn't like some faulty data or an outlier or somebody left the microwave door open or something, right? So the SNOOS program, the SNOOS project, involves 7 neutrino detectors that are located, 2 of them in Italy, 2 of them in Japan, 1 of them in China, 1 of them in Canada, and believe it or not, 1 of them in Antarctica. The Antarctica neutrino detector is really cool. We call it Ice Cube, and it's really neat. But these facilities themselves, I mean, you can see in these photographs, they look like something out of science fiction, if you ask me. They look super neat, so I would love to visit one someday, but I don't know if they'll let me in. They might not be able to get me back out. So anyway, just another fun example. Oh, and that's right, I got another third one. This is also very relevant because this involves a telescope that we'll talk about. We'll talk about ALMA in just a moment. But if you remember the very first picture of an event horizon around a black hole, this came out in 2019. This happened. This was possible because a collection of radio telescopes around the world. And what was really neat about this project is because of the distribution of these radio telescopes, you can see on the map over here on the left side, you essentially ended up with a radio telescope that had an equivalent aperture of the diameter of the Earth, right? You essentially have an Earth-sized radio telescope when you do something like this, and you do some interferometry using multiple different radio telescopes that are scattered around the world. Because in most radio telescopes, like we'll see with ALMA, it's multiple dishes that are separated by some amount of space. And if you know the distance in between those 2 dishes, you can use them essentially as like 2 eyes. And the more dishes that you have in your array, the more resolution you get. So you've got telescopes scattered around the world, radio telescopes, you've essentially got an Earth-sized radio telescope, which is the only way we figured out how to actually get a photograph of an event horizon. This was the first one in 2019. That is the supermassive black hole at the center of M87. And I believe in 2021, I think it was 2021, 2022, they released a picture of the Sagittarius A star, the supermassive black hole at the center of our galaxy, the Milky Way. So definitely a pretty cool project, right? And then, of course, my cat stepped on my phone and accidentally swiped away my notes. Thanks, Nova Cat. Say hello one last time. Okay, down on the ground. Let me see if I can find those again. Apologize. In the meantime, I'll get a quick drink of water. Okay. I'm going to keep them a little bit closer to me this time. Okay, now we can move on. I promise. We're on our third part, so hopefully, I don't get too carried away. But we've got some time. We're going to talk a little bit about some of the instruments that I visited while I was in Chile. I spent a lot of time talking about time domain astronomy and multi-messenger astronomy because these are, again, the flavors of astronomy that we're going to see a lot of global participation in. So, and that's, again, one of the things that we spent a lot of time learning about and talking to people about during our time in Chile was this sort of global astronomy project and this global astronomy industry, I guess, or community, if you will. So, the first one I have on my list is an observatory called Gemini South. You'll find Gemini South on top of Cerro Pachón in Chile. It's on top of a mountain range. It's only a couple thousand feet above sea level. And it's an optical and infrared telescope. In case you're curious, the mirror is about 26 feet wide. The primary mirror is about 26 feet in diameter. But what's really neat about this telescope is that it has a twin. Hence why they decided to name it Gemini, right? You have Gemini South here in Chile, but you also have Gemini North in Hawaii on top of Mauna Kea. So with these two telescopes combined, you are only missing about 2 degrees of declination of the night sky. These two telescopes cover the entire sky from declination positive 89 to negative 89. So you're only missing right around the north celestial pole and south celestial pole. So essentially with two telescopes, almost like with the Event Horizon telescope that we saw, all those radio telescopes, right? You have two telescopes spread across Earth, and they're able to cover more of the night sky. But these are excellent facilities at essentially just general observation, general astronomy. In fact, a significant portion of general astronomy observations actually go to these two telescopes. So on any given year, both of these observatories serve about 400 discrete projects at any given year. They are just churning out data to nearly any project. It's also one of the only, if not the only, professional observatories like this that is easier to get. It's like the easiest one to get time on. So they have a lot of programs with school districts and especially in the regions that these telescopes exist, where schools and museums can actually get a little bit more access for themselves, for education, since these telescopes are part of those communities. So it's a little easier to get time on Gemini North and South. I mean, again, it's never a perfectly easy process, but it's certainly easier than like James Webb, for example, the JWST. But one way that a lot of astronomers describe it is as, I guess, what you could call a follow-up machine, which isn't anything negative by any means. What it means is that Gemini North and South are great at a multi-messenger astronomy, right? Maybe you're not watching gravitational waves all the time, although Gemini South and North did assist in some of those LIGO observations and helped provide some extra data for those projects. But if you have a project and you ran out of telescope time and you want to do some follow-up observations, or maybe you have a run of observations and a couple months go by, maybe you need a little bit more data, or maybe you want some optical data to add on to your radio observation, whatever it might be. It's an excellent follow-up telescope where, because it's a little bit more accessible, it'll be a little easier to get time. A lot of astronomers use it for that. So you'll see a lot of supernova observations and things like that come to and go through Gemini North and South. But overall, it's a really interesting pair of telescopes. I've got some pictures that I took while I was in Chile. You can see the observatory itself from the outside, and you can immediately get a clear look at that perfect blue sky behind it. It's just, I got there and I was absolutely shocked that the skies could look that blue and that clear. Being in Oklahoma, I thought it wasn't possible to have skies that clear. And then, of course, I included down at the bottom of just a photo. We were walking through the facility, and I caught a couple of engineers in some clean suits doing some work, and I thought, snap, that's a neat picture of some people working. However, one thing, this is where the planetarium stuff starts to come in. One thing that I did during my time there is I brought a fisheye camera that allows us to film and photograph in essentially a circular fisheye, 180-degree field of view. So if you want to take a picture of a real place, like where you're standing, but you want it to look good on a planetarium dome, you can't just take a picture with your phone and put it on the dome. I mean, you can, but it's not going to cover the whole dome. It's not going to be immersive, right? It's a flat picture that's only, maybe 4K if you've got a crazy iPhone or something. But if you want a full dome image, what we would call a full dome image, you need to take a fisheye lens. So this is Gemini South through a fisheye lens. And on a flat screen like you're seeing it right now, it's kind of hard to get a sense of the scale. Your depth perception feels a little bit off. But I've been in the planetarium world for 8 years now, and my eyes are getting really good at looking at non-Euclidean pictures. So this is a little easier for me to understand what I'm looking at. But it is very weird. It's kind of a unique perspective. However, I could take this picture, go put it in the dome, and you will stand under that dome, and it looks like it's in front of you, like you are inside of that picture almost. And that's exactly why I took this camera out here. Here's another photograph. They let us climb up here. They put a lot of trust in like 10 strangers come flying across the world to look at their telescopes. They let us just climb up to the top and like look at the mirror. I was afraid I was going to drop something and it was just going to tumble down all of this equipment and just land on the mirror or something, and then I'd be like a few $100 million in debt or something. I don't know. Obviously, no accidents happened during our time there, but you can see that mirror down there at the bottom. There's the sort of secondary mirror up at the top, and it kind of has this tube that guides that light down to the imager and down to the back. But overall, this was a really cool shot that, again, looks great in the dome because when you're sitting down, that natural focus point in our planetarium is about 55 degrees above this bottom line, what we would say is north of the dome, down at the bottom of the picture. So your eyes would kind of rest just above the top of this mirror here. So it's kind of like you're looking out over at the mirror with your own eyes, like you're there. It's really neat. So the next telescope that I'll talk about is the Victor M. Blanco telescope. And this is one that is really interesting. We got to spend a lot of time at this one because of where we were at. It's near Cerro Pachón and Cerro Tololo. These are two mountains in Chile that they look like they're right next to each other, but it's like a 2-hour drive from one to the other because of all the winding roads. A little bit of cat. We spent a lot of time over there because there was some driving involved, so we spent a few nights near these two mountains. So even though we only spent a part of a day at the Victor M. Blanco telescope, they actually allowed us to do some astrophotography during our time there right outside the Victor M. Blanco telescope. So we just spent a lot of time around it, and I'll show you some other pictures here in just a moment. But this is a slightly smaller telescope. Its primary mirror is about 13 feet wide, but it focuses more on wide area surveys and time domain surveys rather than the whole multi-messenger thing. It's kind of intended. A lot of the main projects that Blanco has worked on over the years are projects that, again, involve observations over long periods of time. So one of the ways they did that was with a camera called the Dark Energy Camera, or DCAM. This is a near UV optical and near IR, near infrared imager. And it was essentially measuring, helping measure the expansion of the universe. And not just measure it, we have a lot of other ways to do that and telescopes to do that with, but it was helping understand the dynamics of the expansion, the acceleration of the expansion of the universe. It did participate in some multi-messenger projects, though. It also helped corroborate some data with LIGO and the Planck telescope and the South Pole telescope, which we actually saw. Well, no, we didn't see that. We saw Ice Cube. They're kind of right next to each other, though. But with LIGO, it helped corroborate some of those gravitational wave detections. And with the Planck telescope and the South Pole telescope, it helped spend a lot of time doing some follow-up observations regarding weak gravitational lensing, which is really helpful for measuring galaxy masses and things like that. So again, here's a few more pictures. This one is also kind of right as close to that primary mirror as we could get. And this one looks neat because when you put this one in the dome, it looks like those arms, those struts above you are literally going above your head. It's really neat. But this is a picture that I took while we were there. And this is actually a part of a time lapse that I did. They let us go up here during sunset before they started their science operations for the night. And I took a few pictures over the course of several minutes and put together a little time lapse that looks excellent on the dome. I know it's hard to see on my computer screen because I'm streaming it to Zoom and that's being streamed to YouTube, so it probably loses some of that resolution. But this is 4K, and our dome, our planetarium can achieve up to 8K resolution, but 4K time lapses like this one still look phenomenal on that dome. So as soon as I came back from Chile, I put together that time lapse really fast at like my first day back at the museum after that trip, and I took that video into the dome and put it on there because I wanted to see how good it looked. But this one you can see the sunset over there on that left half of the image. And one of my favorite little details, I don't have the time lapse to show you, I just have the single frame. But you can see that those white clouds sort of roll over the mountains and kind of dump into the valley over here. I don't know if you can see my mouse pointer at all. I hope so. But kind of in between those two domes right in front of the image we're looking at, there's kind of a valley where those clouds pour from that cloud layer down into the valley, and it just looks incredible. So you got a sunset and a bit of a show. It's really neat. All right, that brings us to our next one. This is a big one. Probably heard a lot about this telescope. It's not quite ready yet, but this is a bit of a big deal, and that is the Vera C. Rubin telescope, right next door to some of these other facilities that we've just talked about. And Vera Rubin isn't necessarily the biggest optical telescope or anything like that, although the camera going inside of Vera Rubin is the biggest digital camera ever made, just flat out. This thing is 5.5 feet by 10 feet. The camera is the size of like a small car. It weighs about 6,200 pounds. The camera is definitely a big record breaker. I mean, it's phenomenal. This picture in the top right is the lens for that camera next to a human being. That's the lens for the camera. So pretty cool. But Vera Rubin is sort of an all-sky survey to cover as much sky as it possibly can every single night for about 10 years. During this 10-year sky survey, since it's literally sweeping across the sky and making complete maps of everything that it can see, every night, we're talking, I think, a single night's worth of data is expected to be about 1 or 2 petabytes of data, not terabytes. Right? I've got a couple terabytes of hard drive space on my computer. I used to think that was impressive. This is like 2 petabytes with a P every night for like 10 years. It's a ridiculous amount of data, right? It's an absurd amount of data. These are very high resolution pictures. But the whole reason for that is because if you can essentially map out everything that you can see in a single night, almost every day for 10 years, you can study a lot of dark matter. You can study a whole lot of dark energy. You can even study solar system objects and help map solar system objects like comets and asteroids and things like that. You can watch for transient events, just like any other time domain survey. And you can even use it to help map out some things that are happening in the Milky Way as well. So even though we did get to visit this observatory, it wasn't completed. It wasn't even close. I mean, you can see the picture in the bottom right there is the one that I took of Vera Rubin. But we couldn't go inside because they were still at that time assembling. I think they were just finishing up the assembly of the camera itself, and they were shipping in mirror segments for Vera Rubin. So we actually did get to see a few mirror cells that were wrapped up and everything and packaged outside, and some empty mirror cell movers, like the sort of the frames that they would ship them in. It was a really cool way to kind of get a sense of scale. But we couldn't go inside the facility. A bit of a bummer, but totally understand that. That being said, though, we should see first light for Vera Rubin this year. I think from some of the stuff I saw from the observatory as early as this summer. So fingers crossed. I'm really excited for this telescope. People have been talking about it for a long time. Here's some other pictures. This is a full dome image that I took from there's a small hill right next to it that we're on, because this hill actually has its own small telescope as a way to calibrate and test out data and kind of pre-run some early observations and things like that. So it's kind of got like a little tiny helper telescope right next to it on a small hill. That's the hill that we're on where I took this photograph. And it was definitely still, the facility looks like something out of the future. It's definitely the craziest like sci-fi looking telescope I think we've got out there. Except for maybe this one. Probably one of my personal favorites, and that is ALMA, the Atacama Large Millimeter and Submillimeter Array. They recently extended the name to millimeter and submillimeter. But this is a little different than some of the facilities I've shown you so far. This is a telescope array. This is a radio telescope array. ALMA, at the total number of radio telescopes is 66. At any given time, they usually don't have all 66 operational. And that's kind of by design. It's kind of hard to keep 66 gigantic telescopes running simultaneously all the time. So usually they're running something close to that, but it also depends. But before I get to why it depends, it's kind of broken down. Not every telescope is identical. 50 of those 66 are 25-meter radio antenna that were purchased and supplied by the United States, Canada, and the European Union. Now, the partners from East Asia that are involved in this, that would be South Korea and Japan, those two countries provided 4 12-meter radio antenna and 12 more 7-meter radio antenna. So it's not 66 25-meter radio telescopes. It's a collection of a few different sizes that were provided from different countries from around the world. And you can kind of see, at the time when we went up there, that top right image was a picture I took when we went up to the top. And when we were up there, the wind conditions were horrific. Actually, we got to see them do basically what's called their oh crap maneuver, which is when the winds are so bad and the conditions are so bad, they do this, where the telescopes are almost nearly vertical, to basically prevent them from taking any damage. It's kind of like their last resort. They actually had a term for it. I don't remember off the top of my head. I just remember them describing it as like oh crap, it's really windy. It's like 50 mile an hour, 60 mile an hour winds. Something might get knocked around, and we don't want that to happen. So that was unfortunately happening when we went up there. But we still got to go up close, and I'll show you some up close images in just a moment. But what I was mentioning earlier is that the number of telescopes depends on what they're doing. So they're not always using all 66. They can't, because not all of them are always operational. But what's really neat about radio arrays like ALMA is that they have different configurations. So they can actually have array baselines as small as only 150 meters, but they can also have array baselines as large as 16 kilometers. So that's a very wide, a large gap in how small they can pack all of these together and how big they can spread them out. And again, remember I was saying that with arrays like this, the more instruments you have, the higher the resolution you get. So if you want something as wide as 16 kilometers, usually you're going to want to use a lot of telescopes to fill out those gaps. But if you're doing a 150 meter baseline, maybe you're looking for a specific frequency of radio emissions, you can do something much smaller with fewer instruments and still get really good resolution. You're just going to see different frequencies. Now, you might be wondering, how in the world did they change all these? These things look gigantic, and they are. In fact, a single one of these antenna is about 115 tons. These things are big, and they are each. I thought I wrote down like the. Oh, never mind. Our diameters are there. That's right. They're not all the same. I literally just talked about that. But to move all of these, to change their configuration, or maybe they need to do some extended repairs on one, they have to move them somehow, and they use these gigantic haulers, these vehicles, similar to like a NASA crawler, how NASA moves, like these days it's the SLS, out from the vehicle assembly building to the launch pad. It's a giant vehicle just made to move a rocket. Alma has two haulers, not crawlers, and I'll show you a picture of one in just a second. But it's kind of like a big claw almost, and they go and scoop it up, lift it up, and then drive it to wherever it needs to go, whether that's to a specific location for that configuration, or maybe they're taking it back to the, what do they call it, the operations and support facility where they can do repairs. If they were driving from the array operations site, which is where these telescopes are all sitting right now in this picture, if they're taking it from there, the actual observation area, down to the facility where they can repair them, that trip for one antenna takes about 8 hours of driving. It took us about like 15 minutes, 20 minutes to get up there in an SUV. And they have to drive that slow with these things. It's kind of impressive. So I want to show you some actual useful pictures, but really quick, one thing that Alma is known for are the donkeys and the alpaca. We did see a few alpaca, but it's when we were in a car. We didn't get good pictures of them, but there were donkeys everywhere. So I just love the Alma donkeys, and I wanted to share them because it's kind of funny. They're just like hanging out, minding their own business. Unlike my cat, however, who's not minding her own business. So back to more important stuff, though. Here's a full-dome image of one of those telescopes. Again, they put a lot of trust in us, surprisingly. They're just like, yeah, go take pictures, have fun. I like walked up and touched it just because I was curious. I was like, can I touch this? Like, I just want to like have this as an experience, as a memory. They're like, I mean, yeah, don't trip or anything, or don't like pull a lever or push a button or anything. But they kind of just let us hang out, and there were a lot of safety precautions. But because they were kind of in their oh crap mode, essentially everything was shut down. Normally, you'd be very concerned because you don't want to be near these things and they accidentally start moving, because then you have a 115-ton dish that's turning right towards you. Not a very good thing. So that's actually what those fences that you might see on the left side of that antenna are. That's the safety radius. So I decided to be, after I got my cool experience, I decided to be a good kid and stay back behind those fences. But these dishes are like incredible to experience up close. They're like way bigger than they kind of look in those photographs. So a picture like this to bring back to the dome was pretty important to kind of hopefully get that sense of scale. And then of course here's the crawler as well. Also looks much smaller than it is. This thing is insane. Currently it's carrying that white structure there. That weighs 115 tons. It's like a test weight, so that they can either run tests on the vehicles themselves or do training, whatever it might be. You don't always want to train with an actual telescope, so you need some kind of a dummy, and that's what that is. And they were using that as a way to show us, believe it or not, how agile these crawlers and haulers actually are. Oh, now my cat is caught in all my wires. There you go, kitty. But the cool thing is that there's a guy down here in the bottom left. He's wearing black. Again, I don't know if you can see my computer mouse, but you can kind of see them there. Oops. In the bottom left of the image, That is the guy that's driving the thing. He's got basically a remote control. It's about this big, a big panel, and he's just driving it like it's an RC car. And he's like a kid at a birthday party playing with his new birthday toy or something. Like he's just driving around and having a good old time, and asking him questions and talking to him about what some of the things that he does and what it takes to do something like this with so many people that are involved, and while being safe and protecting your equipment and also protecting your people. Like hearing stories from people like this operator was really one of the best experiences out of the entire trip. Seeing things was awesome, but talking to people like that who work at these places was, in my opinion, just as important, if not more important. And that brings us to our last section that I wanted to talk to you all about, which is the people. And again, I've shown you some like planetarium pictures of things that I took these photo pictures and I bring them back to the dome. And yeah, sure, I can make a planetarium presentation or show out of those. But what actually are we sharing the most? We talk about these telescopes a lot, especially ALMA. ALMA does a lot of research as well with exoplanets. It worked on the Event Horizon Telescope, like we mentioned. It's really good at looking at protoplanetary disks and looking at baby planets that are forming around newborn stars and stars that aren't quite formed yet. It does a lot of great things, and so we talk about the telescope a lot as it is. So what is it that I actually brought back that I share the most? And it's all the people that make it happen. Because you're talking about some of the largest collaborative projects, certainly some of the largest collaborative science projects that are happening on this planet. You're talking about projects that are literally on opposite ends of the Earth from one another. One thing that I couldn't really show in the amount of time that I have is that facilities like ALMA and Gemini and other places like that are always being manned. There's always somebody there controlling them, but they don't always have somebody there physically. So they have these rooms where they just exist on a Zoom call, and you can walk in and nobody's in that room that you're in, but you just look over at this monitor and there's a bunch of people over in the UK or a bunch of people over in Chicago or over at MIT or Cambridge or wherever they might be, and they're just hanging out, eating their lunch, doing their job, and they're just there. It's this massive collaborative effort that I think was probably the biggest eye-opener for not just me, but also I would say probably most of the people that I went on this trip with. Because we all know a lot about the telescopes. Maybe some of us do. Maybe you're new to astronomy, but you might have heard of some of these facilities. But in the world of amateur astronomy and in the world of education, we spend a lot of time talking about the telescopes themselves and looking at information and reading about the telescopes themselves and the awesome projects that they do. Rarely do you ever actually get to expose yourself to the people that make it happen. And again, that was the biggest eye opener, because if you want something like 66 100-ton telescopes to be moved around so that somebody can study exoplanets in a couple days, if you want that to happen, it takes way more than just 66 people. Like, even if you got one person focusing on one antenna at a time, 66 people is still not even close to enough. It takes a lot of work. And when you visit places like this and you meet all these people and you see what they do and why they started doing it in the first place, and you ask them, what got you into this job? What do you love about your job? And things like that. It really paints this picture of just how impressive it is that we can accomplish some of these things. And the reason that we can accomplish some of these things is because we're working together. Humanity's overcome a lot of crazy things over the millennia, right? Over the hundreds of thousands of years, and throughout the entire history of planet Earth, life itself has overcome a lot of incredible, arduous challenges to get to where we are today. But sometimes with the internet and, we all have our homes and we kind of go to work and we come home and hide away from the rest of the world, and we're kind of with our families or maybe some of our friends sometimes, and we spend time with some coworkers, and maybe we get out occasionally. It's easy to forget how many other people are out there, and also how many of those other people are more involved in your life than you actually think. There's a lot of strangers out there, of course, that we don't know, but in some way, shape, or form, we're all connected to each other in that sense, where we all provide something, in this case, science, to the rest of the world. So that was probably the biggest eye opener for me. It's something you're like, yeah, I'm telling you right now, you're probably thinking, well, yeah, duh. It's a big telescope. Of course, it's going to require a lot of people. But for some reason, for me, I just didn't really click until you visit some of these places. And some of these people, I mean, it was incredible to walk into some of these facilities and just say, what do you like about your job? Like, what got you into this? How did you even end up in a place like this in the first place? Just out of curiosity. And they'll just tell you everything. They'll just lay out the whole story and share all of it because it's likely that most people don't ask them questions like that. So one way to kind of really drive this home, something that I think is really important to bring back to Oklahoma, is this next slide here. Because you have to remember, majority of the people that visit the Science Museum, and specifically, maybe not specifically, but not just the museum, but I'm also including the planetarium, majority of the people that walk into our planetarium have little to no familiarity with astronomy. Of course, we get guests, a lot of members of the club come sometimes, a lot of people from OU come sometimes, and maybe some people who are just nerds and like astronomy come to our shows, and they know a little bit more, or sometimes a lot more than the average person does, just because of their interest in the subject. But that's a very small group of people. The general public knows very little, if anything, about astronomy at large, and certainly about big astronomy projects like ALMA, for example. So when a lot of people visit a place like a planetarium and they're exposed to these telescopes and these big projects and these big discoveries, they think of a telescope maybe, and probably a room full of a couple people wearing some lab coats. Astronomers don't wear lab coats. I've never seen one. So, but that's the picture that a lot of people get in their head. There's kind of this disconnect, right? And so one thing that we like to bring back is a couple of a few numbers that kind of help paint a better picture of what these places are actually like. If you were to take just ALMA, because ALMA gave us a lot of stats for things like this, they've got it broken down and it's really interesting. If you take just the ALMA telescope and you take every single person that's employed by ALMA, it's about 300 people, about 5% of everybody employed at ALMA, whether they're in Chile or they're in Santiago, Chile, or they're somewhere in the U.S. or somewhere in Japan, wherever they're at, if they are employed at ALMA, about 5% of them have only a high school degree as their highest form of education. 32% of those staff have technician certificates or certifications like that, or maybe they're tradespeople, things like that, and that's their highest form of education. 37% of all staff has a bachelor's degree as their highest form of education, and only 9% of staff has a master's, and about 17% of staff have PhDs. So it's pretty clear immediately that an overwhelming amount of people who work at ALMA are probably not astronomers, right? And so when you break it down by occupation, you see that exact same thing. Only 14% of people employed by ALMA are astronomers. 13%, almost the same amount, are administrative staff. Not your bosses and stuff. That's a category of its own at the bottom. Administrative staff are cooks and chefs, people who work in the hospitality. This telescope is 16,500 feet in the air. It's at the top of the mountain. If you're going up to work, you're not going up for an 8-hour shift and driving back home. You're staying for probably a couple of weeks or for a few months at a time. You're working on shift. So they have dormitories, they have kitchens, they have public facilities, they have gyms, they have auto shops where they can repair their trucks and cars that they drive around everywhere. They have huge HVAC facilities and huge R&D facilities. They have their own hospital and medics at the tops of these mountains. So you have people that are in the hospitality hospitality jobs, people that make food for everybody and feed everybody, people who keep facilities clean, people who keep the AC running, right? That's administrative staff are people like on the hospitality side, right? So that would be like your kitchen staff and your maybe your cleaning staff and stuff like that do these very common necessary tasks at these facilities. About a third of the occupations, employed in Alma are technicians. So that would be your HVAC techs, your mechanics, your welders, maybe your tradespeople. 23% of those occupations are engineers, and this is kind of a broad category as well. You'll have a lot of different types of engineers, and about 17% of staff, more than there are astronomers. 17% of staff are just your managers or your supervisors, people who make the teams work well and who help organize things and get things done, doing what managers do, right? Doing what supervisors do. Sometimes that might mean standing around and watching them do the work. I don't know, but doing what supervisors do, which is often, in most cases, sometimes an important thing, right? So when we bring these types of numbers, we don't always show people a formal list like this. I try to make a pie chart. I didn't really have enough time, and I couldn't make it look pretty either. So I just kind of wrote a list. But even if you could make a pretty pie chart, not everybody's really going to care too much about it. So instead, we just talk to people about, especially when they ask us questions. Maybe they think, oh, I really like astronomy, and I would love to do that as a job someday. I just don't feel like I'm smart enough to be an astronomer. Well, two things with that. Number one, nobody's too dumb to be an astronomer. You just got to find the right place to start. So you're never too dumb or stupid to do astronomy or to like astronomy. Second problem with that is that even if you don't want to do the math, maybe you're not a big math fan, maybe you're not a big college person, and maybe you'd rather go to trade school. Guess what? That's most of the people who are employed at a place like Alma. People who do all sorts of jobs, and not just the people who write the papers or look at the pictures and take the pictures and the astronomers themselves. There's a lot more that goes into a place like Alma. So that means that there's jobs for everybody. A lot of people that I met during our time there, people like you'll see in these images, some of the pictures we took, had no idea that they would end up working for one of the most important observatories in human history, or the largest radio facility in human history. They had no idea. They just went to trade school, or maybe they went to school for electrical engineering because that's something that they think is really exciting, and that's what they're into. And then they came across an opportunity to work at a place like Alma, and that's where they ended up, and they fell in love with it. That's a lot of the stories that we heard. Is I'm an HVAC guy. I've been doing HVAC since I was 18. I went to trade school. And or I'm a welder, and I've been welding since I was 18, 19, 20 or whatever. And I was looking for a new job, and I found one here and had no idea what I was getting myself into. So it's just really interesting to hear stories like that of how anybody and everybody can be and should be involved in some way with these facilities. But another really neat group of people that we got to meet were not just the people at Alma themselves, but it was the people around Alma and the people who are native to the land that a place like Alma is actually on. So we got to meet with a lot of indigenous folks and indigenous communities around Chile. And this was this was another eye-opening experience during our time there, is sitting around and listening to stories, their stories about the night sky and the pictures that they see, the stories that they tell about what they're seeing in the sky, learning about how they perceive astronomy and how they perceive the night sky, and how they share that with each other, and learning about a very different culture and very different ways of viewing the universe and understanding the universe. This was a really interesting experience because, like I just mentioned, Alma is built on indigenous land. It's in the middle of the mountains in a desert, but there are multiple indigenous groups that lived on that land prior to Alma existing. So one of the efforts that Alma spends a lot of time with is giving back to that community, not just the small towns that are around Alma, but also to the indigenous communities who are native to the land that they're standing on. And they give back in a lot of different ways. There's so much that you can kind of go into, but that's kind of one thing that's really impressive about the operation of a facility like Alma is how much they pay their respects to the people that are allowing them to be on that land and build these gigantic telescopes. They have a lot of very environmentally conscious efforts to preserve the land that Alma is using, and they have a lot of funds that go to the communities, whether it's to build new roads, new wells, new infrastructure for those towns and communities that are around, Alma itself as an institution gives back to these indigenous people as a way to, again, just give back to them for letting them use their land. And it's really interesting to see how that works and what that looks like. And as part of our experience, we got to visit some of these reservations and meet with a lot of people and literally sit there and listen to their stories and listen to their music and learn from them about how they perceive their night sky. And it was just awesome to be able to do something like that. Now, if a lot of this is interesting to you, this is again where we kind of bring in the planetarium stuff. I'm almost done talking, I know, I promise. I can't hear anybody, but I'm hoping that I'm not hearing any snoring, right? I hope I haven't been too wordy. But if this is something that interests you, maybe you're more interested in the indigenous folks who are involved in Alma. Maybe you'd like to see a little bit more first-hand experiences and testimonials or interviews with people who work at Alma. Maybe you want to learn a little bit more about not just Alma, but astronomy in Chile in general. Maybe you want to learn more about how these facilities operate together. One thing that is incredible is something called Big Astronomy. This was a planetarium film that was produced by people who went to this program, who went through ASAP to visit these facilities in Chile, and they wrote a grant when they got back home and came back out and filmed an entire 30-minute long planetarium show. It's essentially talking about what I just shared with you, but in a little bit more detail. More detail in some areas, and certainly with more people in that conversation. But the best part about this grant that they got for this show, which they call Big Astronomy, is that the entire show is free. In fact, you don't even have to have a planetarium to go watch it. You can look up this show on YouTube right now, and the entire 30-minute film is on YouTube for free. And in a flat screen format, no less. You don't have to look at the weird circular picture thing. They have it as a flat screen format that'll work on your television, your computer screen, your cell phone. And you can watch that entire film for free. In fact, we have this show, we offer this show in our planetariums, in our planetarium occasionally on Saturdays. The last show of every Saturday in the Love's Planetarium is a Spanish planetarium show, usually presented live by a native Spanish speaker, who happens to be my wife, fun fact. Shout out to Isabella. But occasionally when she can't be there on a Saturday, we show this film instead because it's also not only recorded in English, but it's also recorded in Spanish as well with a native Spanish speaker narrating, not translating an English script, but narrating it herself. And actually she's an employee at one of these facilities as well, who happens to be an educator. So the entire show is incredible, and I encourage you to go check it out. It's 30 minutes. Like I said, you can watch it on YouTube for free. And it's really neat to see some of the shots that they got for this film and some of those interviews and things like that. But that's pretty much it as far as what I wanted to share with you all. There is one last thing, though, just a fun little bonus thing. During my time in Chile, I wanted to do sort of a funny joke, like a funny bit that I could help use to remember my time there. And the funny bit that I came up with is something that I call get a load of this guy. Not get a load of this guy, get a load of this sky. And there are no less than like 10 pictures of me standing in front of something profoundly beautiful, just sticking my thumb up going, get a load of this guy, right? I don't know. I thought it was funny. The people in my cohort thought it was funny. I only found 3 of them, but there's like 10 or 15 pictures of me just doing this throughout Chile, being a menace, I guess. So I thought I'd share it because I'm pretty proud of it. I thought it was really funny. But anyway, with that, that is all that I have for you. If anybody has any questions or anything like that, I'd love to answer. I don't know how that works with YouTube. If somebody wants to chime in and help.
So Waylon, can you hear me?
Yes.
Okay, and hopefully everybody on the stream can hear me too. My audio level seems to indicate they can. So, yeah, if people want to ask any questions, they can do that on the YouTube stream chat, and I'll get those relayed over to Waylon, and we'll see if he's got good answers for us. So, or maybe it's a question for me.
And while we're switching over, I just want people to understand this program, ASEP, is not just for educators, for university or high school people or for planetarium educators. We've had along on my 2018 trip, we had some really good astrophotographers, and we had some prior to, I guess they probably went the year before, Matt Dietrich, and some of you know him, and they now have special tours where they will take you to Chile and do astrophotography. Not just Chile, he has some other places that he sends people to in the United States, so don't think you have to go abroad. The other thing is don't be afraid to reach out in another country. They know English better than we know Spanish. I can guarantee you will be comfortable. They are always trying to practice their English with you. And extremely hospitable culture, and the people, as Waylon has said, are second to none, really.
All right. So far we're not seeing any questions on the live chat, but we'll give it a couple more minutes here. Just as we're probably getting close to the end of our stream here, I'll go ahead and reiterate a couple of things about our next meeting is going to be on May 9th at 9 o'clock, hopefully back at the Science Museum of Oklahoma. Yeah. And then our regular club nights again at CRO are April 19th and April 26th, which is also the Mazier Marathon. We've got the first Friday public viewing on May 2nd. And Saturday, May 3rd, I didn't mention this before, but Saturday, May 3rd is Astronomy Day. So everybody be ready to go out and celebrate that. It sounds like fun. Hopefully there'll be clear skies for Astronomy Day. I think that's about it. I'm not sure with the kind of the audio issues we were running into. I was scrambling around. Did Mitch have a chance to talk about anything that we could hear?
I think we covered everything else. The one thing I wanted to make sure is that tomorrow night is novice night at Windsurfers Point. So for people who have a telescope and want to know how do I set it up, how do I, find things. Yes, we are at full moon, but it's a good object to learn how to use your telescope at even point. So please come join people and check the forum and make sure it's going to happen, that there aren't clouds that intervene and things like that. But that's the most immediate part. On the first Friday of the month, we will be at Arbor Gardens in Moore. So, and that's been highly successful. Even the school kids that have come out, they want to keep it there. And so I thought Mitch needs to know that. Waylon, can you give a little bit? The other thing that we're planning is Sally's Night and in June, and that will take the participation of everybody in the club to do some little part where they would bring their telescope for evening viewing. And we have an Army of Sea Stars that will help in the twilight hours. Waylon, do you have anything else you want us to be thinking about as we try and plan? Because we have a board meeting coming up on Tuesday.
Well, one thing I will say is our timeline has changed very slightly. We originally discussed, and I think in your post on the forum it mentions 7 p.m. to 10 p.m. We've shifted that, slightly from 7:30 p.m. to 10 p.m. So it's just starting 30 minutes later than we anticipated. Other than that, one thing I might recommend actually is maybe if you all want to talk about getting some, I don't know if you all want to bring handouts. I know that occasionally at meetings you'll have little sky maps for the month or something like that. If you want to maybe tack on something like that with something that also provides information about the club, that could be excellent too, if you want to discuss that at the board meeting coming up. But other than that, I probably will have more details in May as well, because we are getting close to kind of finalizing our activity list and things like that. But we're going big, we're going home this year. It's going to be a very fun event, and so I'm excited. I'm currently trying to get a 1,000-foot egg drop approved. Don't ask me how I'm going to do it. It involves a drone and some very unfortunate eggs, and a lot of safety space, probably bigger than the antenna I talked about. But other than that, I'll probably have some more details in May. But that's the only change so far to logistics.
I had a couple of ideas. I'll fly them by you before Tuesday. I had sent them out to people to think about this. So even if we did something on the inside, had some very short presentations for people who want to know about the club, know about how to get started, the night sky in June, globe at night, things like that. Some quick presentations that we could run possibly. But we'll talk to you and get your advice on that.
Sure thing.
Thank you.
Okay, and we did have one question, but it's not related to your presentation, Waylon. But you may know something about this. Tom Graham was wondering if anyone was in the club was actively following T Corona Borealis, the blaze star, and looking at it with anticipation every single night. I did. Somebody on the chat also said that Mitch has been taking a look at that, at least periodically. But have you been doing anything with that at the Science Museum, or be keeping tabs on it?
Yeah, we've been bringing it up and kind of reminding people every now and then about it. We actually have an event at the museum coming up in 2 weeks called it's a SMO 21 event, a 21 and over event, and the theme is Museum Heist. So we're working on a show right now, kind of funny, about a star that goes missing in the sky that was stolen, but it turns out it just got obliterated by a white dwarf star. So the example being T Corona Borealis. So we actually almost have a show about that star coming up for this special event, which will be fun. But other than that, we're just waiting to see if somebody catches it so that we can go outside and look at it at night. And there's not really much else we can do except for wait, I guess.
Gotcha. Well, thank you very much, Waylon. I'm always fascinated to see how things have progressed, because Vera Rubin was pretty much a hole in the ground in 2018. So, but for anybody else, there are lots of programs that would get you, if not to Chile. There are programs that, well, I call it acronym soup. The National Observatory for Optical Astronomy, NOAO, is really now NOIR, the National Optical and Infrared Observatory. And they have programs for just amateurs. They have programs for high school teachers, for college educators, and where they give you the experience with the data from these telescopes in Chile and probably even in Arizona, but where the kids can actually design research projects answering certain questions. So I think that's a big thing, to not just look at the night sky and take pictures, but to ask, how come? Where did that happen? How is it moving? How are things changing? So, and it all comes from all these big data collections. So thank you very much, Waylon. And have a good night. And tell that kitty was entertaining.
Yeah. Yeah, she's a little clingy, I guess. She likes attention. But yeah, thanks for letting me chat. And I guess we'll see you all next month.
See you all. Thank you. Bye-bye.
There was one more question asked, and again, not about the presentation, but Tom Graham was wondering about the wind damage out at CRO. And yes, we're addressing that. A plan has been put together. There's temporary fixes in place, and then the wind damage wasn't that terrible. It was like one piece of paneling, but they're going to combine that, replacing that one panel of sheet metal that kind of peeled off the edge of the roof, with also rebuilding the roll-off roof on one side. So we have a solid engineering plan to do that, and approval from the board to move forward with that. So that's being spearheaded by some of the Four Domes guys out there.
kudos to those guys for pitching in and doing what they do best, which is pouring cement pads and building buildings out there at CRO. All right.
Thanks, Chris.
Okay. Well, everybody, I guess I should wrap it up, and we'll hopefully see you next time at Science Museum, Oklahoma, again on May 9th. And not that we mind doing these virtual meetings, and it's kind of nice to put these out on YouTube for everybody to see. But we do like the in-person meetings if we can get them, and when we so, we'll see everybody there. All right.
Have a good night.
Okay.
Bye-bye.